Greetings again from Playa Bonita, Dominican Republic. So, we had a flight plan from Isla Grande to El Cate, and we wanted to do some work to do some flight planning. So the first thing that we should do is set up a cross-country flight log. And I broke the log down just for simplicity. I know for VFR we'd probably pick some more checkpoints, but for simplicity we had our departure from Isla Grande, then top of climb, then the Punta Cana VOR, Papa November Alpha, then Mike Delta Charlie Yankee, Samana El Cate. Remember that our time and distance and gallons used in the climb to top of climb was given to us by the POH. So I went ahead and filled those in. We would get our headings or true course and distances, and we could go ahead and fill those in. We're going to start on the wind side of the flight computer, and we'll follow the steps. You'll notice at the top of the E6B there are steps listed. So the first step says to set the wind direction under the true index. And our wind from our forecast was in the direction of 110. Then we will make a mark up from the center, it says. So what I usually do is I'll put my center circle, and I'll have to apologize, the E6B that I have down here does not have a very visible circle on camera. But I'll set the circle to 100 because there is no 0 on that wind side of the computer, and I will use 100 as 0. And it says to mark the wind up from that center point. The wind was forecast to be 20, so we will call 120 20. If 100 is 0, 120 is 20, and we'll make a mark. Next, it says to set our true course under the true index. Our true course was 285. So we'll set 285 under the true index. Our next step says to slide the mark that we made, or the wind mark, to our true airspeed arc. We'll notice that we have our numbers in corresponding arcs that come out from those numbers. And the first true airspeed that we'll look at is what was given to us by our time and distance to climb is 110. So we'll slide that mark to 110 knots. Our next step says that we will read the ground speed under center, and we'll see our center dot at 129. So that's a ground speed of 129 knots. Our next step says that our wind correction angle reads between the center line and the mark we made. So we will notice the center line running up and down the center of the card. Our wind mark is on the left side of that center line, and it is approximately 2 degrees to the left. If we look up above the card, it shows us WCA, wind correction angle, and it will say minus left plus right. So since our mark was on the left side, we will subtract it from our true course, and we will get a true heading. Of course, if we were actually flying this, then we'd take magnetic variation into account, and we would get a magnetic heading. But for this exercise, we're getting our wind correction angle. Now, when we get to top of climb, our true airspeed is going to change. So we will slide our wind mark to the new true airspeed of 204 knots. Once it's there, we follow the same steps. Our ground speed under the center, which is 223 knots, and our wind correction angle reads between the center line and the mark we made, which is approximately 1 degree to the left, so -1. Then we have a change of direction when we get over the Punta Cana VOR. So what we must do now is to put our new true course under the true index. So we would put 312 degrees under the true index. We would continue to follow our steps. So we would slide our mark we made to our true airspeed arc, and we would see that now we have a ground speed under the circle of 222 knots and a wind correction angle 2 degrees now to the right side, so that would be plus 2 degrees wind correction angle. So now that we have our ground speed and distance, we can switch sides of the E6B and we could solve for time. And we'll read right on the front of the computer that if we set our MPH, or knots, we'll use knots, underneath the triangle, then distance will be on the outside, time will be on the inside. You can remember that by you are setting the triangle, which says 60 underneath it, to 223 knots, or nautical miles. So nautical miles is on the outside, minutes is in the inside. Then we would locate our distances for our leg. So at 223 knots, we are flying 110 nautical miles, and we'll notice if we look at the 110 that it is 30 minutes, which makes sense. 110 is about half of 223, so that makes sense. Notice it's not exactly 30, it's someplace in the 29 range, but I always round slightly up because we're going to use these to figure fuel, and I'd rather error high than error low and run out of fuel. So our next leg was at a ground speed of 222 knots, so we'll set that under the triangle. Look for 88 nautical miles on the outside, and we'll notice it's around 23.8, but just for simplicity, we'll round that again up to 24, so we'll say that that leg is 24 minutes. Now that I have my times, I can solve for gallons used in each leg. So I will set my gallons per hour under the triangle, and we said in our example problem that our POH told us we'll burn 20 gallons per hour. So we'll put 20 under the triangle, or opposite the triangle, and then we'll look for our leg times. Well, the first one's pretty easy, right? 30 minutes. We'd cut the 20 in half. We don't even need the computer really, but let's just look to be 100% sure. And when we look at 30 on the inside, because remember time is on the inside, gallons are on the outside, it would be opposite the 10. That'll be 10 gallons. Makes perfect sense. Then we would look at 24 minutes, and as we look at the 24 minutes, you will see it opposite 80. Well, we don't burn 80 gallons in 24 minutes if we only burn 10 gallons, so make it make sense. Move your decimal point a place. We need 8 gallons for 24 minutes. So now we have our flight log complete. We could add our columns, and we would see that we are going to travel 218 nautical miles. It is going to take us 1 hour and 5 minutes. And we need 24.5 gallons, 10 gallons, of course, for a day VFR reserve, 30 minutes. If we could fly this at night, which we couldn't, can't fly single engine into El Cate after dark, but if we could, of course, we would look at the 45 minutes on the inside, and we would see its opposite, 15 gallons, so we would need a 15-gallon reserve. So that's part 1 of our discussion. I'm going to make a second video to do the other problems, so I'll see you there.